Hello everyone, my name is Roger Fari and I would like to welcome you to another video. In this video, we are going to focus on data structures. Data structures, by and large, are the way we organize our values or data. And we go about this organization in a way that is going to benefit the need that we have, that we are using the data for. Right, so there are a few famous and widely applicable data structures that we're going to learn about in this video. We're going to get introduced to them in this video. And in the couple of following videos, we are going to see how we could create them, use them, and see a couple of examples in a couple of the future videos. All right, so let's get started and look at the slides. So like I said, data structure is the specific organization of value and data. And the most important thing you want to take away with you from this slide is that we organize the data in such a way that it's going to benefit us for our needs of programming, right? And these are the few well-known data structures that are being used, and it's the ones that can have wide applications. In this video, we're going to cover a few of them, and also I'm going to tell you why we are not at the level to be able to cover some of these in this series of videos. But let's get started with a list. List is basically an ordered collections of items, right? And the way we create a list is by a bracket, right? So this is the way we signify a list, and by just having our items. So for instance, we can have different item. We can have an integer, we can have floating point, we can have negative numbers, and so on and so forth, right? And this is a boolean, right? So it's a collection of items. But what's important for the list is the fact that you have an order here. So the order is very important. It means that 2 is the first value here, and after 2 comes hello, and after hello comes 2.3. And this order is important for list, and if we want to use list for an application, we have to pay attention to this structure. And Python uses bracket as a way to signify list, and the famous operation for a list is append, right? So appending is basically adding one more item to a list. So for instance, I define A as this list, right? So it's an empty list, and then I say a.append 20. So what's going to happen, A is going to become this. I can then say a.append hi, then A is going to be added as 20 and hi, right? So you can use this very useful function to add stuff to this list, add stuff to this collection. And that's the famous operation of list. So now let's talk about tuple. Tuple is basically a collection of items that are ordered, but the difference between list and tuple is the fact that tuples are not immutable. They cannot be changed, right? And the way Python signifies tuple is using parentheses, right? So once you create a tuple, it's like a variable. You cannot change it unless you just change the whole thing, but you cannot append to it. You cannot take one value from it. For instance, I can say B is equal 20, 10, hi, right? And every time I get, I say B, I'm going to have access not only to B, but to all of these elements. I could say, for instance, B 1, then I would get access to this. The only difference is, B doesn't have append or other functionalities that we could change stuff. Like for list, I could be changing, I could say B.append, and I add stuff at the end, but for a tuple, that doesn't work that way. And, tuple, because the way it's structured, takes up less space in your memory. At the same time, the way that you need that data structure might be in a way that actually having a set structure might be suitable for your solution. Another similar data structure is a set. The difference between a set and a list is that a set is not ordered, so the order is not important. The way Python signify set is by this type of brackets, right? So the list bracket was this is a list bracket, and this is a set bracket, and you can have different types of items here, and like I said, the order is not important. When you have a list, right? I mean, you have a set. It looks like that it's, they're like ordered, but the orders are sort of like in the background, might change, so you do not have any control over the orders. For instance, you might be introducing a set like this. For instance, it could be saying 5, 2, 1, 5, 5, 3, right? And when you print C, what you will get is this 1, 2, 3, and 5. The reason is, Python order it, or show it in a way that it works out for itself. So it uses to optimize memory. So it orders it like this, and also, of course, it's going to remove the duplicates, right? So you can only have one value in this set. One of the applications of set it actually is, for instance, if you have a list, right? So for instance, you have this list, right? So this is a list, right? And I have brackets. So you've got 1, 2, 2, 2, 5. So and it's like I mean, we've got only 4 elements here. Imagine it's 1 million elements. One of the things you can do is use the function set in Python and say your list, and E basically is going to automatically drop the duplicates for you. So you will get 1, 2, 5. So that's one of the very easy way to drop the duplicates. Use the function set, and of course you're changing the type of your data, but you don't have duplicates, and you have to be aware of that. So now we want to switch gear. So the list, set, tuple, all of these are one-dimensional, linear data structures. But with dictionary, you have sort of a little bit more complex data structure. With dictionary, you're going to have a collections of items, but each item has a key and has a value, right? So the way dictionary is defined is by this syntax, right? So you've got a key, right? The key can be anything, right? So let me remove this key, and then you've got a value, and again another key and another value, and so on and so forth, right? For instance, I can have a dictionary like this. I can have, for instance, name, Ruhollah, this is my given name, and then age 33, and I can have height 189, right? So this would be a list. Pay attention, with the list you have a key and a value. So you could say something like, if I want to access the value of age, and it gives you, and then it gives you 33, right? So the way it works out, the way it is, every value is connected to a key, right? So when you have a list, the difference between a list and a dictionary, so for instance, in this list, if I give this a name, for instance, let's call it this G 0 is going to give you 2. So these are typical indexes. G1 is going to give you hello, right? So if for whatever reason you need a collections of items that you want to recall each element using a specific key that you want to use, then dictionary. But list can be used like a dictionary if your sort of keys are typical integer indexes, 0, 1, 2, 3, 4, and so on and so forth, right? So that's the difference between dictionary and a list. So now let's move to a little bit more customized data structure. These data structure are not in Python. So these first, right, list, tuple, set, and dictionary, we have a data structure in Python as these names, right? But stack is not a data structure that Python has it, but you can simulate it using a list, right? But what matters for stack is that, it's an ordered collections of items, but you can only use stack in a LIFO manner. So last in, first out, right? So it's actually works like a stack, right? So imagine you have a stack of values, right? So this is a stack of values, right? So you've got different values here. You've got 500, you've got 200, you've got hello, right? You've got hey, and the only operations you can have is you can have push, right? You push a new value into this. For instance, you can push 100 and it will come and sit on top, or you can pop and this 100 will pop out, right? So it depends on what comes first and after that. So you basically use it just like a stack in real life. If you have a stack, you put stuff on top of it and you take stuff from the top, right? And the famous functions are push and pop. Like I said, Python does not have a stack, but you can simulate a stack using a list. We will see that. Another data structure is queue. Is another sort of collections of items that is ordered, but it works like a queue. It's FIFO. It's first in, first out, right? So if you have a queue or a line in a coffee shop, so the first thing that is going to be taken care of or serviced is going to be the one that came first, right? So this is the one that came first. This is the server. And if someone comes, they're not going to come cut in here, right? So they're going to come at the end of the list, at the end of the line. So that's queue. So it's first in, first out. And the famous operations of queue, so if this is sort of like a queue that we are using, you've got a rare member, and we've got a front member, right? So we've got other members here. Let's, whatever they are. And then you can dequeue, meaning that this gets to be served, dequeue, or you can enqueue, so you can add another right? So this can be used for data or for values that you need these types of structure. You want to have a FIFO structure. Whatever comes into this collection first, that's going to get out also first. Next, we're going to cover array. Array is basically a list that you have only numbers, right? So it's basically a list of numbers. So you cannot have strings, right? You cannot have strings. It has to be, everything has to be number. As long as you've got numerical values, this is a array. And matrix is basically a two-dimensional array. So you've got, an array of arrays. So this is one array, right? Another array, so on and so on and so forth, right? It's a two-dimensional array that is the structure works in a way that the inside arrays have specific structures. So if you have 2 by 2, so let me use here. If you have 2 by 2 array, so you're going to have a structure like this. All of these are number. Or if you've got 3 by 2, right? So it's going to be something like this. So it's a two-dimensional array that you can have, and the best way you can use array in Python is using the module NumPy, which we will see together. In this video, we talked about some of these data structures that I introduced in the beginning. A few data structures that are very famous and are useful for data analysis and programming are linked list, tree, and graph. At this level of your knowledge and your expertise and understanding of programming, these are a little bit sort of like beyond what you can handle right now. For you to be able to work with these data structures and understand them, you're gonna need to have a fundamental understanding of object-oriented programming that cannot sort of like realize itself for you unless you have a little bit more experience in programming itself. And I don't know if I will get to create videos for that in the future, but at this level that I'm creating these videos, linked list, tree, and graph are a little bit beyond the scope of what you can handle right now. So in this video, what we managed to talk about list, dictionary, queue, stack, tuple, set, and matrix. We got only introduced to them just a little bit. In the couple of videos that gonna come after this video, I'm going to actually show how we can create these in Python. Show a couple of the more important functionalities of them, and also we are going to see a few examples that how these data structure can be useful in real cases. All right, until next video.